How many of you guys would appreciate having until tomorrow for your test corrections?
Not me.
If you have your corrections ready to go, you can staple them, put them in the folder in the back. Otherwise, I will go ahead. The majority of the class forgot this weekend. I'll make corrections due tomorrow.
Thank you. Thank you.
Theoretically, your 7.3 should be done today, though. If you didn't do your corrections.
I did my homework. Look at me, everybody. I'm so funny.
Alright, cool kids. You should have these notes ready to go.
Almost.
Nice thing is, exponential growth and decay, we are getting further into differential equations. Our goal by Christmas is to get through chapter 8. Then we can come back, second semester, sequences and series, electrical. But we have a bit more to do until we get there. As soon as you guys have these notes ready, go ahead and put your pencil in your notes, close it up, open your homework spirals. Let's go ahead and go grade what we need to grade. I thought it was 7.3, but I heard someone say 7.2.
What?
We didn't.
Yeah, we did.
But we didn't.
We
We didn't grade.
I did
Okay,
7.3 was.
guys, calm down. I think we're all like freaking out about what I had just said that's correct. So hold on. I said, I thought we would grade 7.3, but then someone said 7.2, and then we all went, what? You just need to be like, oh yeah, that's right. Like Alan did. Oh yeah, that's right. Cool. Let's grade 7.2 and 7.3. Here, we'll be back to the notes in just 1 second.
Yes.
7.2, I think we hadn't quite finished the section or something, and then we just forgot to go back. I forgot to go back, I apologize. So let's go and grade 7.2. 7.2 was on U sub, right?
Yeah.
So let's check the U sub, and then what was 7.3 on? Loopy at all.
Once you learn the odds, just plug.
Alright, here we go, cool kids. So first of all, U sub. First of all, U sub.
Except for yourself, I will actually do this one.
Okay. Number 6, you guys can check. Pretty easy with 2e to the x, integral of secant, tangent, and secant. Had to use a quick power rule, plus c. Number 18. Did they give you who to make you?
Yeah.
Yes.
But you did have to be careful, it was off by a constant, hence why we have 1/4 sine of u, 2x squared plus c. Yes, you could have checked it by deriving, we always know that, right?
Mm-hmm.
So, final answer, 1/4 sine of 2x squared plus c. Number 20.
No?
I'm getting these right this week.
Number 20. It was u cubed, which is u to the 4th over 4, but we had to also be careful of offsetting by a constant. But when you do u to the 4th over 4, 28 over 7 was already 4 over 4, ends up being just 1 plus c. Found it? Number 70, they gave us a derivative and they gave us a clue from which you should have been able to find plus c.
Yeah.
Yeah, because you had the whole every other odd.
Yeah.
That's right.
I almost did all of them, but I didn't.
Yeah.
I almost did all of them as well.
No, I think so. Wait, I'm so confused.
Somebody thought it was evens and odds, so it's even sadder.
I wasn't sure. I don't know what I did, but like I didn't get that. I got like sine x over sine 6, or ln of that plus 6.
Can I do it on the board?
ln of sine.
Sine x over sine 6, and then plus 6 outside of it. So it's like
just choose to keep out random. Put your hand down.
Okay, this is the only question for this entire homework, and we're doing it quickly because you still have to grade 7.3. So don't worry, no one's going to be able to volunteer, but you can all collaborate.
oh
So coming back, when we take the integral of cotangent of x,
I just plugged in a random 6. I don't know.
oh, okay,
Yeah.
that makes more sense. Well, you're supposed to plug in that y was 6 when x is 2.
Yeah, but I had like sine of 2, but then when I wrote it, I
Oh,
had
and you
sine
changed it
6.
to a 6. Okay,
Yeah.
that makes more sense.
Okay.
That makes sense. And kiddos, could you have done 1 over u times u prime?
Yes.
Yes. But what property did they use to simplify the procedure?
Ellen.
they use the quotient property. So some people might not have thought to use the quotient property before deriving. They said, cool, it's an ln, let's use the quotient property, then derive. Because you could have done 1 over u times u prime, it should have worked out to be the exact same thing. It might have just been a little bit messier. But there we go. Okay, with that, let's go grade 7.3. Sorry, any other questions on, besides what EOO means? I apologize, I thought you guys had seen
Every
every
other
other on before. But a lot of you that didn't know came and asked me, hopefully it just saved you some work.
I miscalculated, like, I was going to do them, and then I accidentally did, like, I didn't skip an odd, so I did like 31 to 33 instead of 31 to 35, and then I was off.
Just write in like a colored pen and be like, sorry, numbering got off. It'll probably be okay.
I did the same amount of problem.
Okay, yeah, that works. Done.
45.
45. I'm just gonna go to the bottom of this real quick. Was it a solving integral problem?
Yeah.
Okay, can you give me the integral?
Integral from the, sorry, not from, it's a secant x.
Just secant?
Yeah. And then I gave a clue.
Ah, what was the clue?
To multiply it by secant x plus tangent x over secant x plus tangent x.
Just secant times tangent?
Plus.
Oh, secant plus tangent?
Yeah.
Now, kiddos, I know there is a forever card for this one. However, they were asking you to find where the forever card came from. So those of you that went straight to the forever card, good job memorizing, but hold on, pause, and let's see if we can actually understand where it all comes from. What happens when you multiply secant by secant x plus tangent x, and why does it help?
Secant squared secant.
Okay, you do have secant squared plus secant x tan of x. Because you're just multiplying by secant over 1.
This one.
What would your u be?
Secant x.
So if you make your u the denominator, what was nasty before, sorry, there's a plus in between, but you can't quite see it. What was nasty before was that we didn't really have any good u stuff, like 1 over cosine, but then you need sine, it's not there. But now that we multiplied by this conversion factor, then what would our u prime be? Or what would our du be?
Secant tangent plus secant squared x.
And so it turns out that what they had us multiply by, secant squared, is exactly what we needed. So we end up being able to solve dx is du over secant squared plus secant tangent. Those end up canceling. We end up literally with just 1 over u to u. Which is why the rule says the integral of secant is ln of secant. So usually what we did, like last year, was like, oh, take the derivative of this. Yay, it works eventually. But this was actually how to go from the integral with a quick multiplying by 1 creatively. A complicated one, but a quick one, to the actual rule itself. So it's going forwards instead of backwards. Unless you think of integrals as going backwards, then it's going backwards to go forwards to go. Never mind. I'm done. Yeah.
Would you just be able to go back to 20, please?
Yeah. As I do, let's get ready to check section 7.3. In section 7.3, integration by parts. Who can raise their hand and quote to me the formula after I call on them for integration by parts?
Oh, wait, oh, you said it?
No. There's no way.
B times du?
I'll give it, but I was looking for the entire formula. And I didn't know the entire formula.
Integral of u. Integral of u z b is equal to u times v minus
Nope.
the integral.
No, it's not it.
Close enough.
You said it right.
No, he said
Yeah, you did. I think you did.
integral u
Yeah.
dv.
That is right.
No, in your face, no.
Okay.
You're welcome for it.
Question!
I don't even like.
Question!
Yeah, who else said no?
Hey. Positive attitude in class. That's what citizenship measures. I haven't had to look at this rubric for you guys' grades. Okay, coming back.
Ooh, awesome.
Coming back. Last one. When Oh, I have two good ones. Okay, here's one of them. When would the tabular method be especially useful for all and not just some? When would the tabular method be especially useful for all and not just some? Caroline?
Oh, wait.
This is rigged.
No.
She was the last one to
Lucy?
When you have to do repeated integration by parts.
Ooh, nice. That's a good way of putting it.
What'd you say?
We have to do repeated integration by parts. And can you go a little further, Lucy?
Oh.
What's going to be in there where you know you're going to have to do repeated integration by parts?
Oh, like the loopy ones? One trig?
No. You're on the wrong one. You're on the wrong one.
What?
However, she did just help out and say trig loopy. Who can finish that thought? Loopy isn't just trig. Who can finish that thought, but also give when the tabular method will be specifically useful when something is in there? No one.
Trig and E.
For the loopy.
I just got that wrong.
And then what's the second part?
I got the second part.
The other part isn't, can derive to 0. That's second.
And secondly, right?
Oh, what is it?
An exponential.
What do you have that you're deriving that can go to zero?
A polynomial.
She earned it. Polynomial. You have the loopy. You said polynomial?
Yeah.
She already had her candy, so these are fine. Okay. We might have more candy opportunities, so let's go check 7.3. Alright. Here we go.
Mine is either yet.
Mine is good,
UV minus the integral of VU.
Oh, yeah, that's right.
Right? It's the formula. It's the formula. X times e to the x minus e to the x. Don't forget your plus c. No killing of red canvas.
He killed the right hander.
I showed you.
I always do it.
Number 8. Number 8. Did you actually have to do, wait, there is a polynomial, tabular method, right? Well, did you actually have to use the tabular method and go all the way to 0? Or were you able to?
It's useful.
What did I do wrong?
Twas easy.
I wouldn't have made the u the t squared. I would have made the u the l and the t liate. There's a log in there.
I did.
Usually liate is the way to go.
Oh, did I integrate?
Final answer would be 1/3 t cubed l and the t minus t cubed over 9. Now, could you have pulled out that 1/3? I suppose, but the plus c is stuck. That's kind of messy. Number 20. It's a loopy one. Now hold on. Did they show the loopiness? Yeah, it did. Is it messy? Yeah, it is. Is it impossible? No.
It's not.
It's not. They went ahead and pulled out an e to the negative x over 5. Sorry, a negative e to the negative x all over 5. You could have actually had that distributed in. But at the end of the day, you did need to get the integrals to match on either side. Get the integrals to match on either side. Be careful, don't kill a seal. Be careful of your negatives distributing. Be careful of adding that to the other side. Remember, the whole point is that we can loop it, and if we can make these integrals match, we can combine like terms. Multiply both sides by 4/5. But don't forget your plus c. Plus c will not naturally occur on this one because you still had an integral to solve, but you're combining like terms, and in doing so, you have to get your plus c with constant integration in. It's a good idea. Huh? That's for sure. Oh yeah, kind of a 6 grade. Because it fits me a lot looser since I lost it. 24. Ooh! Why is this a green tabular method 1?
Because it says so right there.
Because your u is a polynomial. Stop. Because you're you're not going to be choosing, you're not going to be choosing trig over a polynomial. Choose the polynomial. You can use your tabular method in order to go. And oh, hey, look, they do it like I did. Yours did. Go team. I don't know, it's just faster. But
So why did he call it tic-tac-toe?
What?
Because there were 3.
because they're.
But it's like not even like the game.
I've done nothing.
That's what I'm still confused about. This whole, it just doesn't make sense.
Okay, I don't even know if he called it the tic-tac-toe method. In that moment when there were 3 in there, he was just like tic-tac-toe, like boom, 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 like 1, 2, 3. Like he might not have even been calling the method tic-tac-toe.
Probably just.
I would say tic-tac-toe to remind you.
rhythm that keeps it in your head because you played it as a kid.
Maybe because like plus minus plus, so it's like XOs.
Could be.
Maybe, but that still doesn't work.
I have to research it and see if you actually call it tic-tac-toe, but I would say, yeah, same thing, and like, sometimes there's 4 or 5 or 6.
That's what the book said.
Intensity.
38B, 40C. 38B, 40C. And then we're done. Kiddos, the nice thing is on the AP multiple choice, that's about the only time this ever shows up, they're usually fairly straightforward ones. They're usually fairly straightforward ones. But the loopy ones, the college professor would expect you to see every now and then. It might show up on an AP, but almost always the ones that I see, like in my practice book in the back and on practice exams, it's almost always a polynomial with a trig or a polynomial with an E, where you cannot deal with it without the enrichment parts. Anyway, just to give you a quick AP heads up. Gabby?
Could you explain again for the tabular method how to determine which one's positive and which one's negative?
Oh, for the tabular method, you always start by well, okay, hold on. Kiddos, you realize when the plus or minus, when the positive or negative, and it always starts with the positive on the first connection, the first UV, always starts with a positive and a negative. This doesn't mean the overall term is going to be a positive. It might, but if you look at the answer, it's a positive, positive, negative, negative. Like, what? Because this doesn't mean this is what the answer is going to be. This means you're going to multiply the multiplication, or you're going to multiply the UV times a positive one. So you're going to go ahead and have the U times V times a positive one, which is why it's positive. The U times V, it's a negative times a negative one. Or you can think of keep the sign, switch the sign, keep the sign, switch the sign. So whenever you're doing a tabular method, the first one's always keep it, because think it's your first UV. Okay, whatever, UV, keep it. But then every time after that, there's a minus with the integral, so then you have to go ahead and flip it, or switch it, and then switch it back, and then switch it again. So maybe switch is a better way of putting it than positive. Does that make sense? Okay. Good question, Gabby. Sorry for not clarifying that earlier. All right, section 7.4. I apologize. I did not ask for questions on 7.3. Did we miss anything?
There's no homework questions for you either, Corey.
Yeah, Alan.
On the tabular method, instead of putting plus or minus, can we put K and S?
Keep switch, that's fine. I think that's fine. Here goes, section 7.4, if you remember from last year, exponential growth and decay. It's not impossible. It's not impossible, it's just a little involved. This book deals with it a little bit differently than last year, but it's not horrible. Just remember, when we have separation of variables, oh, how important are separation of variables?
Very.
One of my BC kids, last year, after the test, came in and said, this FRQ, I think I got it all wrong. After we looked at the FRQs, I'm like, how'd you get it all wrong? Like, I didn't do separation of variables. I didn't understand what it was asking. I was looking at bad rules. Because we know, if this shows up on an AP, it's either our luckiest or our worst day. If we don't see it, there's 7, 8, 9 points out the window. Which can definitely be the difference between a 4 and a 5, and it, I think, was for this person last year. So coming back. This is a big deal.
At least they passed.
And this is someone who, the BC kids were all more than adequately prepared for that class, or for that test. It was a small class. Stop. I should have just said a few years ago and lied, and now you guys are all thinking about last year's class. I know, which is why I did. Well,
So every time you say a few
Coming
minutes,
back.
last
A while back. I should have done that. So you already know. Okay, coming back. But long story short, this can literally be the difference between a 2 and a 3, a 3 and a 4, and a 4 and a 5. This FRQ, if it's there. It's your luckiest day. Yeah, it can be, right? It can be 5, 6, 7, 8. I've never seen it to be 9 points, but I have seen it to be 8 points. Okay, so it's a big deal, and even those who are more than adequately prepared, sometimes the wording can mess you up. Those of you guys that freaked out from the silly potatoes or the silly bananas or the silly whatever last year, it didn't matter. When we looked at the FRQs, it didn't matter. The banana was fine. Didn't matter. All right. So, yeah, it's almost better if you ignore what they're talking about and just look for the math words. Okay. Original differential equation. Question, how did they separate this one to make it solvable? What was the math they did?
Oh,
They-
they
They subtracted the x squared, then they,
Multiply by dx.
good. Do I have it in terms of y in terms of x?
Yes, ma'am.
Integrate, go. How about this one?
Divided by sine of x.
Divided by sine,
And then
multiply by dx. Cosine over sine, you can make it cotangent, or you can think cosine over sine u sub u is equal to sine. This one, woo,
Just divide by x and divide by.
I wouldn't say divide by x in terms of
Multiply by 1 over
simplicity. I would say multiply by 1 over x on both sides, and then multiply dx.
Yeah.
So you can say divide by x, it does go away, that's true. Now, could you have also gotten there if you had multiplied the e to the y plus 1, then divided the x, that you would have had to move the e to the y plus 1 as well. In terms of y,
Yep,
in terms of x,
yep.
alright, let's integrate. Okay, so, ready, set? Go. Whenever you see a y prime, it's the same thing as so solve accordingly. Yes, sir.
Will you ever give us like the integration of parts for a
Separable differential equations?
Yeah.
I don't think I've seen one, not in recent years. I don't think I've seen one. It's not to say they couldn't. Because if I haven't seen it, that just means it might be coming, right?
Amen. It's so true.
Want us to integrate or just separate?
Separate, then integrate, once you have it legally ready to go. Separate, then integrate. Let's assume the directions were. That's almost always what the Let's assume the directions were find y equals f of x. It's almost always the directions. However, I did not give you an initial condition, so you do get to have a plus c, or, ooh, maybe not a plus c,
Minus c.
but a c.
We do e to the.
Remember, plus c vertical translations are only on easy.
I don't like this.
There's no initial, so.
Yeah, no initial, so there is going to be a c, but remember, it might not be a plus c.
No, it's like that. This is what I got.
We're missing your dx.
Make sure you guys agree with the separation.
Did you get it? Wait for you, Ellen.
We'll figure it. So I don't know how to grade what.
Yeah. You'll see this.
If you don't do that, you're basically.
This group has changed.
Yeah.
I do examples. I haven't done examples since I did the first node of the pre-calc.
1 over y dy.
I remember these
dy is just the differential, so when 1 over y, as long as it matches with dy, I integrate. Same reason on dx.
Okay.
Okay.
That makes more sense. And then you make it e to the e to the. So it's c times e to the 1/2 ln by squared.
Oh, yeah.
Question. How do we get y by itself?
E to the
E.
Oh, that,
There's stuff
C
to absolute value.
to the 1/2 ln of x
not
squared.
sure.
Yeah.
How do we deal with the absolute value?
What the X value?
The other one after value?
You can't do anything with the x, everything. Not everything is absolute value.
Wait, C has to be greater than 0?
Well,
Well, because x can't be negative.
E can't be negative. So C has to be
greater than or equal to 0.
If you're given an initial condition, you're gonna plug in, you're gonna see what's going on, right? Anyway. And we can make, or we can solve for the C according to that initial condition. When you have no initial condition, that's when we have a little bit of issues. But as you guys are just talking through, e to the power of will always be positive unless there's some sort of other translation, reflection, something other's going on. But that would be seen on the outside. And so if the absolute value of y has to equal something, yes, it has to be positive. So we could go ahead and say y is equal to ce to the 1/2 ln of x quantity squared. We could go ahead and put that extra condition for c greater than 0. That's the only way that y will, or I should say that this side will always be a positive. We could add that condition, that would be okay. When we start having adding and subtracting and other things going on as well, that gets a little bit tricky. Yeah, okay. Oh, sorry, John. I just saw a hand.
Would you have to restrict the x? Give me negative either.
Well, I mean, the natural domain of x, if there's an ln in there, is that x has to be greater than 0, so I think I'm okay. But remember, e to that, even if this was a negative, which it'll never be because of the squared, but even if this was a negative, that would be 1 over e, which does not make the whole thing negative, just makes it really small. Good idea. Yeah. C in general can definitely sometimes be negative, especially with exponential growth and decay. But in this example, since this does need to equal the absolute value of y, then I do have to just see a squared.
Is it greater than or equal to?
So,
Oh, it could be already broken.
but if
Yeah.
you solve for C,
Oh, it can't be.
Y has to be. So if you have to point Y, and you have the absolute value, you can break that positive greater.
Right. So then the other side of the equation has to always be positive since the absolute value is there.
So C has to always be positive.
Alright, so I would say positive or 0, technically Katrina's right. It could be 0. But Kyle, that's not in every single example, because there could be something like y plus 1, so where we subtract, and that might make a difference. So we know that whenever we just have a plain old y prime is equal to, we just multiply the dx, no big dealio. However, this entire idea of solving differential equations with separation of variables is especially important when we do have an implicitly defined differential equation. What do I mean by implicitly defined? Yeah, you do. Implicitly defined differential equation. What am I talking about?
X is inside.
X's and Y's are both inside, right? Implicitly defined. X's and Y's are both inside. So then why is this one a little more interesting?
And the dx is on the bottom,
Yeah.
and so is the dy.
I mean, dy could be on the bottom if we divided it, but we always need that differential up top. So we're going to automatically multiply the dx on the other side, right?
Couldn't you have just like flip both
Yeah, or
sides?
just flip them. Just x over dx, y plus 4 over dy.
Oh, you mean like cross multiply?
No, like.
No.
I mean, you could have flipped them, but we still need to
And then you
separate
just
them.
divide by x and then multiply by dy. I mean, I
But
guess-
you would still have an x here. You would still need to do basically the following, because the x would now be on top and would need to go to the other side. So ultimately, we still need to somehow multiply by 1 over somebody, right? And to be honest, the separation in this one isn't meant to be the tricky part. Because do need to multiply up the dx, you do need to divide the y plus 4. Remember, whenever we have a y with a plus or minus, we do need to divide that entire term. Need to keep it grouped. But what's interesting is when we go to integrate both sides, what do we end up with?
ln of y plus 4.
Pause. Did you deal with du?
Yeah.
Did you think about it? Who was your u?
Y plus 4.
Who was your du?
1.
Okay, then you're allowed to jump there. But if you didn't think about it, then we're having issues, right?
Then you do it either.
Yeah, if it was y squared plus 4, if it was 3y plus 4, we'd have to offset by a constant. Now you guys do see that, okay, undo with e to the, but what's interesting when we go to the other side?
I don't know, you just get to see.
Oh, it's x, c times
E
x.
to the y plus 4. No, yeah, y.
cx.
We can't put the c in front, but we have c times e to the ln of, why is that interesting?
That cancels out that.
E to the ln are inverses of each other, so we can just say,
Absolute
So
value
c
of
to
x.
the x.
C absolute value. Minus 4.
But then that's just like random numbers.
is it possible in this case for c to equal a negative number?
Yes.
Yes. Oh, no, because then y is.
Because it needs to equal an absolute value on the other side, true?
Mhm.
Okay, so we know first of all that c must be a positive. Okay?
Okay.
So if we make c a positive, then we can get rid of these absolute values.
Mm-hmm.
True?
Then you subtract 4. You just subtract 4?
Give me 1 second. Is there any way to get rid of the other absolute value?
Why do you do It's a function, why would you want to?
If you want to make sure everything is positive, then wouldn't you make everything absolute value?
But the problem is you can subtract from 4.
If you plug in 0, won't it be negative 4? But it has to equal times the value.
0 equals.
Try to give an example of initial condition. Let's say that y equals negative 5. Let's say, sorry, that's a y.
Well, absolute value is c be 0.
If y equals negative 5 and
C equals 2.
let's say x equals 2. What must c equal? That was my initial condition?
1/2.
Then that
Well,
gets
if
your
c
negative.
equals 0, it's negative 4.
1/2.
Then 0.
No, it'd be okay, because if I plug in negative 5 plus 4 would be negative 1 absolute value, would be positive 1, and then 2 times 1/2. Now let's look down here though. Would mine still work? Yeah.
If you plugged it into the bottom, it will work then.
Okay,
Oh,
that's
is that
fine.
what you were saying?
Uh-huh.
Oh,
So if I plug in my negative 5, if I plug in my 1/2 times 2 minus 4, I would end up with negative 3.
yeah.
So what's the dilemma? What went wrong?
Add 4.
Huh? No, I need to subtract 4.
You have to put absolute values on negative 4 to make that positive. Well, we just box it dirt.
We just box the third, just box the second?
I mean, you could,
Because isn't this technically an initial condition that's possible in this one?
couldn't you
Yes.
put a negative sign in front of the C and make everything absolute value?
Maybe we have two different C's.
But the problem is I need my y to be negative. I can't make everything absolute value because y is allowed to be negative. Just when he adds 4, he's going to flip to
Oh,
become
everything
positive.
absolute value, put a negative on the outside.
Maybe just swap for two
But
C's.
y in this one, y in general is not always negative.
You sure?
It's a struggle.
I believe you.
Alright, we'll talk about tomorrow mathematically the deal with absolute values. What went wrong? We're finishing 7-4 tomorrow. Homework due Wednesday. Finish up your corrections tonight.
Yes, no, doesn't back up both of you. Oh, thank you, what I get? No doubt, what grade did I get specifically? I don't know, but I just marked off what you did. What do you think I got? Did you agree? I can't, like, give you, like, what you